synthesis reactions, decomposition reactions, single replacement, double replacement reaction. Some people call them displacement, by the way. It doesn't matter. It's the same thing. And my favorite, combustion reactions. So these reactions basically, they just happen in life, right? Like it's nothing that we made up. Our job as scientists is to identify what happens in nature and to label it, to give it name and to give it, to reason of what is happening, right? In my opinion, how did God do that, right? That's just my belief. But anyway, the synthesis reaction, basically you're just gonna have two, whether they're elements or molecules, you're just gonna have two components to a reaction. So component A and component B, and they are going to become something else. If you haven't realized it yet, the word synthesis is just a very fancy, complex word to say to make, right? That's all it means. Anytime you hear that in science, whether it's biology, chemistry, anytime you hear the word synthesis, it just means to make something, right? So you're building something, some sort of building. So basically when you have two things and they become one, that's a synthesis reaction. The decomposition is the opposite of a synthesis, right? So it's just going to be, if I go from C, right, that C would become A plus B, as simple as that. All right. Again, this is going to be a molecule. This is going to be an element. The element is not going to break. The molecule is going to break, or the compound, and then it's going to divide into its components or some sort of components of it. And then we have the single replacement reaction, which I like to think of this. A lot of my students get this very confused, the single replacement and double replacement reactions. And I like to think of it this way. This is like a telenovela. And those of you who don't know what a telenovela is, it's like a soap opera. And it's basically, we have this couple, right? And I want to make a disclaimer that I am not condoning any type of infidelity. But a single replacement, basically, you have this single person over here. This is a couple. And that person is attracted to one of the members of that couple, right? And you guys have seen it on a soap opera. It's like, oh my gosh, I love you so much. And they're like, oh, but I'm a married person. Right. And then they're like, but you're my true love. Right. And then they swap and they replace that person that they're with that other person. That is a single replacement reaction, which is horrible. But in nature, it's okay. In chemistry, I should say, it's okay. So A plus BC, it's going to yield one of two things because it depends on which one this person is attracted to. Right. So if person A is attracted to person B, B is going to be the positive component of this component, right? So A plus B, this A is going to have to be negative if it's going to be attracted to the positive side. So it's going to become BA. But if this A happens to be positive, so I'm actually going to call it D. So if D was positive, and it's the same couple, right? So the positive is going to be attracted to the C because the C is the negative component of that molecule or component. So this is going to become DC because we always write the positive part of the component first and then the negative, all right? So if this was the positive, this would be the negative, so it would be BA. This is the positive, this is the negative, so it would be DC. I hope that makes sense. Now, the double replacement reaction, it ain't no soap opera anymore. This is like Jerry Springer stuff, all right? So this is two couples. And the couple goes into Jerry Springer and they're like, oh, my wife is looking at the neighbor, but the neighbor is married. But then he ends up being with the wife of the neighbor, kind of like that. It's awful. But anyway, I hope you guys it makes sense to you guys. So if we have a couple here, right, and we have the second couple, right, and they are attracted to each other's partners, right, then this A is going to match with D, right, because A would be the positive and D would be the negative. And then B and C, when they combine together, is going to become CB, because C would be the positive, B would be the negative. It would never be the other way around. You would never have like A and C or B and D. That is never going to happen in chemistry because only the opposites attract, right? And that's where that came from. But anyway, the combustion reaction is actually going to be, we're always going to have either a carbohydrate or a hydrocarbon. They're very, very similar. They have carbon and hydrogen in them, but carbohydrates have also oxygen. Hydrocarbons don't. But it doesn't matter. The point is that it's going to be a carbohydrate or a hydrocarbon if it has an oxygen here. And that is going to combine with oxygen gas, and that is going to yield carbon dioxide and water. If you guys think about it, right, every time you have burnt something, right, one of the two ways to put out the fire would be to either put water on it, which is a product of it, so then it won't happen, or you cover it, right? So if you suffocate the fire, the fire goes out. So if there's no oxygen, the combustion cannot happen. Carbon dioxide and water are going to be the products of that. Carbon dioxide, if you guys know, if you inhale smoke when there's a fire, right? That's basically what you're inhaling. You'll be inhaling CO2, which is not good. So please don't start fires, even though they're fun.